Good morning, good evening, wherever you are. My name is Mark Borstein. I'm the CTO of Trello Security and the co-author, Kubernetes and Enterprise Guide Second Edition. We have gone on quite a journey so far. If you think about it, we've deployed we've gone through authentication, authorization, talked about the dashboards, and today we are going to talk about OPA, Open Policy Agent, and admission controllers, validating webhooks. Now, why is it important to have OPA or similar tool installed in your cluster? Well, because Kubernetes doesn't give you everything you need to secure a cluster. Remember, Kubernetes is a platform for building platforms. And so you deploy kubeadm or Kind or any other Kubernetes, you don't have everything you need to run a cluster, let alone a secure cluster. And so specifically the niche that OPA fills is that authorization niche. Who's allowed to do what? And that becomes really important, especially when we start talking about multi-tenancy. Because while we've talked about RBAC protects the API server, but it doesn't protect your nodes. There's nothing on there that stops people from deploying containers that have all kinds of security flaws in them. There's nothing that stops somebody in namespace X from deploying the same ingress host name as somebody's namespace Y. There are also a couple of security issues around service deployment. So there's all sorts of reasons why you need a validating webhook. We're going to go through, or admission control. We're going to go through a lot of those. OPA is probably the first and probably still the most popular of the generic admission controllers. There's Caverno, that is a great project. They do, they're very Kubernetes specific. And then there's JS Policy, which I'll be honest, I haven't played around with much, but they're a little more generic. They let you use JavaScript. But we are going to focus on OPA in this chapter. And so in this, there are two chapters on OPA. This chapter where we talk generically about admission controllers and building admission controlling webhooks and GateKeeper. And then the next chapter, we're going to talk about replacing pod security policies with OPA. So that's going to be a real interesting one. All right, so we got a bunch of labs in this one. I started out with a fresh Open Unison. Destroy your Kind cluster, go into chapter 6, run the Open Unison script. You're all up and running. So we have that up and running. So I'm just kind of running through here. We start off with what is an admission controller, what is OPA. The really great thing about OPA and the thing that really is, to me, what makes it so powerful is it stores all of its data locally. So what you do is you build something that's just constantly pushing data into it. And because the data lives locally, it's very, very fast. You don't generally write policies that reach out to something else, because then you're losing a lot of the power of OPA. And so then we get into Rego. Now, Rego is an area where people tend to get caught up. The most important thing to know when you write any Rego is basically any kind of complex policy has the following form. Build a set of all the things, build a set of all the things that match your requirement, and see if they're the same thing. And that's what 90% of the complex policies are in Open. Once you kind of break it down that way, the Rego actually doesn't become that difficult. And so now where am I? I'm on page 261. So I would get into GateKeeper. So what's the difference between OPA and GateKeeper? OPA wasn't born in Kubernetes. It predates Kubernetes. I think it was Netflix that where it got its first big claim to fame. But it works real well with Kubernetes. So a bunch of folks came by and said, okay, let's take this thing that is OPA and make it more K8s native. So let's build custom resources for it instead of just embedding Rego into config maps. Let's build some process around it that's very Kubernetes native. And then let's make it a little easier to use it as a mutating webhook. We'll get to that later in the chapter. So the first thing we're going to do is we are going to deploy GateKeeper. So deploying GateKeeper is quite easy. You just go ahead and run kube control apply, except good old copy paste. There we go. All right, so let's take a look at kube control get pods GateKeeper system. No, kgetns. Oh yeah, it's GateKeeper system. Oh, duh. There we go. All right, so we have a couple of different components here. We have the controller, and we have the audit system. So one of the key differences between GateKeeper and OPA is OPA is just a pure admission controller, whereas what GateKeeper does is it takes your existing um, your existing etcd, all of the objects that are in there, and runs it against whatever policies you create. So it'll actually go back and tell you what's failing an audit. So it's not just the admission controller, but it's also applying it to existing pods, and we'll see that in a minute. The other thing that's great about OPA in general is that it's got a built-in testing policy framework, which makes it really easy to build and test your policies outside of Kubernetes. You know, you get a bunch of JSON, you import it into OPA, and you're off to the races, and you can start testing. All right, so let's see here. We're going through the labs, developing an OPA policy. All right, so when do we get to the part where we actually get to test it out? Chapter 8, here we go. So let's go to simple OPA policy, so that's this one. And Rego, so let's take a look at the Rego here. So here are our registries, and yes, let's go ahead and install that. All right, so let's come back here. Ah, that's prettier. Okay, so let's see what we got here. So this is a limit registries is a really common use case. Why do you want to limit your registries? Well, you ideally want to only pull in containers from registries that you trust. You don't want to generally be pulling things directly from Docker Hub. As an example, you want to first import them into your own registry, so that way you have control over what is going on. And then if some bad guy comes in and they say, okay, well, I'm just going to go ahead and deploy BusyBox or Alpine as a base image, this is a really easy way to catch that. And so we've got a couple of different hooks here, or a couple of different rules. So this first one is invalid registry. And the important thing to remember about Rego when it comes to how you write your policies is it's kind of a trapdoor. You know, in a typical and we talk about this in the chapter, in a typical code, you know, something like Java or Go, you're going to assume everything's wrong, and then you're going to say, okay, but if everything is right, then we'll go. So past equals false. You know, are we okay? Are we okay? Are we okay? Are we okay? Okay, good, true. Go ahead. Rego does it a little bit backwards. Everything is okay until it's not. And so you write your policies in kind of the negative. So in this case, we've got a violation function with message and details. So that's going to be the top of our call. And to check invalid registry, we're saying, you know what, we're only going to take images from quay.io. And so what happens is when this rule runs, it's going to get all the input, it's going to get the images, and then for each of those images, it's going to say, if it doesn't start with quay.io, fail. As opposed to, if it does start with quay.io, continue. So you got to get used to working with negatives. So here is our code, and we want to test it, right? So then we come over here. Here are our test cases. And this is what I mean by it's so great that you can test it, because you can just embed the JSON right in there. Let another tool generate it, tweak it as you need to, and you can test your policies without having to use Kubernetes. So that way, when you go to roll it out, you're not testing the, you're no longer testing the policy, you're testing the integration of that policy. We got a bunch of different tests here. So let's go ahead and run our tests. So we're going to go to chapter 8. I'm on page 265. And we're going to go into simple OPA Rego. And we're going to do OPA test dot. And so we've got 7 that passed and we have 1 that failed. The one that failed is test cron job registry not allowed, fail. So this exposes a really important part of developing your policies. The one that failed is if we go to, let's go ahead and find this one. Test cron job registry not allowed. So let's take a look at the test. So here it is. So invalid registry with input. So the input is what your input is to the function. So this would come in as the admission controller. And what this one is, if we get there here, kind is cron job. And so the question is, are we properly looking for images in cron jobs? Now, we're looking for images in pods. So even though this cron job might create a pod, might get past our policy for images, the pod it creates would still fail. That's a little harder to debug though, so you want to try and pick it up as high up the food chain as you can. And so what we want to do now is we want to define a image that, or a function or policy that's going to catch cron jobs. So here we're saying, okay, let's get all input images. This one builds the set of input images from all containers. This one builds all images from all containers coming out of a job template. This is a cron job. So what you're doing is you're saying, okay, let's build all the images that could possibly be, and this is going to match up on it. So we're going to go ahead and save. Now let's run that test again. Everything passed. So that's really the beauty of being able to test it outside of your cluster, is now when we go ahead and roll it out, we're not testing to see if the policy actually works, we're just testing the integration. So we did this part, so let's deploy some policies to GateKeeper. So I am on page 266, and so the first thing we're going to do is we're going to deploy a constraint template. And so your constraint template stores your Rego. So that's the first thing we're going to do. And we're going to come here to YAML, and here's our constraint template. It's kind of interesting the way GateKeeper does this. What GateKeeper actually does is it builds a CRD off of your constraint template. And so now there's actually going to be a type in Kubernetes associated with your constraint template that you'll define instances of to actually enforce the policy. So kind of going through here, the target, so this is the group that the policy is going to go under. Here is our Rego. So this is the same code, it's just put into a template. So let's go ahead and create this. We're going to go into YAML. All right, cool. Kube control create F GateKeeper template. Oh, wasn't paying attention. All right, let's go ahead and log back in. Okay, there we are. And let's go ahead, get CRDs. So now here's the cool thing is, here it is. So there is now a CRD called Kate's Allowed Registries .constraints.gatekeeper.sh. So we're going to now create instances of that as our actual policy enforcement mechanism. So the next thing we're going to do is create a policy. So the policy is an instance of what we just created. So you can see here, we've got Kate's allowed registries. Our kind is Kate's allowed registries. And we're going to match on all pods, all stateful sets, all deployments, and all cron jobs. So that covers most of our top level pod deployment mechanisms. You know, you might have an Argo CD rollout or something like that. But even if they try to build a pod that fails, that pod will still fail to create. And so now that we've got that in place, let's go ahead and deploy it. So policy's been created. And so the first thing we're going to do is let's go ahead and take a look at policy, you know, the audit side of it. So I'm actually trying to remember. It's been a little while. Look at the policy object. Okay, so here's our policy, right? This is the policy that just got created. And what we'll now see that that's been running for a while is trying to see, there's the status, serve generation. Maybe it just hasn't, looking for violations. I don't see any violations yet. Sometimes it takes a minute. There we go. So you can see here that we've got all kinds of violations on the object. It's got 7 violations. So this means that even though these pods were deployed before we deployed GateKeeper, we have a place to look to see whether or not we have an existing violation, something get past the goal. And so it's important once you deploy this, you want something that's watching for violations and alerting you, because whenever a violation comes up, you know, you should know about that. You should have an action item on that. And so what we're actually going to do is let's take a look at the Open Unison, and we're going to go ahead and delete our operator. So that's going to trigger a new pod to get launched. Now let's do kube control get events and Open Unison. And we will see that really lost in here, isn't it? Kube control get describe or get deployments. Kube control describe deployment Open Unison operator. This will be better. Okay, so here's the events, and it's being scaled. However, I'm looking to see, should be an event in here that gives us a violation on the pod. So it failed to create. I'm trying to see. Usually there's a event in here. There's killing. Here we go. Warning, failed create, replica set, error, admission webhook, validation.gatekeeper denied the request, restrict open unison registries, invalid entry. So basically what's now happening is because open unison is stored on Docker Hub, not Quay, it's blocking the request. So that's literally what we want to happen. So let's go ahead and delete that particular policy so we don't break anything else. Kube control delete F. All right, so that's been deleted, and if we take a look here in Open Unison, let's go ahead and kube control scale Open Unison operator 0 and Open Unison. So we'll scale that down, or replicas. Of course, if I remembered that, and then let's scale it back up. And there we go. It's firing up because the admission controller is no longer blocking it. So we've created our first policy by forcing everything to go to Quay, seen it in action, seen the audit violation, and also seen the admission controller stop it. All right, so what else are we doing in this chapter? So that's all great, but if we come back to our limit registries, you'll see here that this is hard-coded, and that's not particularly helpful. It's, if you've got a small cluster or you know exactly what you need to do, this isn't the biggest deals. But as most developers want to do, I like to make generic tools and reuse them. And so GateKeeper gives you this capability. And so what we are going to do is go ahead and define a variable. So if we come to parameter policy, here's our Rego. And so it's a little bit different. Let's do a side-by-side here so you can see the difference. So here, the invalid registry doesn't start with quay.io. Here, we do it a little bit differently, where we say, okay, we're going to build a set of everything that starts with, every input image that starts with the parameter for registries. So you can have multiple registries in the set, because in theory you might have, you might say, okay, maybe parts of Docker Hub are okay, like, Tremolo Security, we're a vendor, we're a trusted vendor. So maybe you say, Tremolo Security, dockerhub.io/Tremolo Security is trusted. We don't have to import those. You still should, but just as an example. And we also want to trust our internal registry. Well, you can write the Rego in such a way to do that, where instead of repeating this rule multiple times, you say, okay, I'm going to build a set based on the image of everything that starts with the input parameter registry set. And so what this will do is this is going to create a set of every single image that matches our condition. Then, and this is back to what I was talking about before, we're going to count the difference between our input images and our valid set. As long as they're the same, we're okay. If they're not the same, that means we have registries that are not valid. So that's the key of writing a complex policy. All of your input images, that's all of the images built up the same way. That part has not changed. And all of the images that are okay, that's being built from this set. Create the set with the value of image wherever the image is in the registry set. And that's how we know we have an invalid registry. So now that we have this Rego, we're going to go ahead and add it as a parameter. So if we come to the YAML, and we look at our template our template's going to be a little different. So we have our Rego, but we also define properties. And so the really cool thing about this is that because it's using a CRD, it can actually validate the input correctly. So it's actually piggybacking off of Kubernetes built-in API validation for CRDs to validate your input into the Gatekeeper policy. It's a really smart way to do it. I thought this was a really clever way for them to go about it. And so it defines this type called registries. So coming back here, that's where this is coming from, right? Our parameters, registries, and it's an array. So now when we define our policy, we can actually define it using a list of registries rather than just a single registry per instance. So let's go ahead and we're going to run a, we're going to go ahead and apply these. So let's close this out. So I'm still in simple. So I'm going to do kube control delete F gatekeeper policy template. And let's go up a level. And we're going to go to parameter of a policy, YAML, kube control create F gatekeeper template. So now we've created the template. And then if we look here at our policy, it's going to look very similar, except we now have this parameter with registries that says, you know what, we're going to allow stuff from docker.io Tremolo security. Create, also know how to type, policy. So now the policy has been created. So let's go ahead and kube control run temp shell rm I tty image busybox. Now, because I'm not putting a registry in front of it, it's going to be docker.io busybox in the Open Unison namespace, and let's run bash. So if our policy is built correctly, this is going to fail. And I actually think that this is, oh, there we go. And here's the failure. Admission webhook denied the request, invalid registry. That's what we expected. Now, let's do the same trick we did before. We're going to delete the operator. Yeah. Kube control, delete pods, L, app gets, open unison operator. So this time, because it's coming from our Tremolo Docker registry, it should be okay. Let's see here, kube control get pods and open unison. And there we go. It's back up and running. So because our policy allows this in our Open Unison namespace, so we're only applying this to the Open Unison namespace. So I try and create a Tremolo pod in a different namespace, it's going to fail. Actually, no, it won't fail at the moment. We're going to get to that right now, or in a minute. But this policy is right now applied to the Open Unison namespace, so we are good to go. So then the next question is, how do you debug Rego? We get into that in the chapter. We talk about using existing policies. So one of the great things about Rego is other people's code. there's been a lot of people who've written code about Rego in Rego, and you get to reuse it. So they're great libraries. We're really going to leverage that in the next chapter when we do node security. So uh, I'm on page 274, and we're getting into enforcing memory constraints. So far, everything's been self-contained. You haven't needed to actually look anything up inside the cluster. We're going to change that. We're going to say, you know what, if there's a resource quota in the cluster, let's make sure that it has the pods have resource definitions on them. Now, I think they've actually enforced this in a later version of Kubernetes, but at least up until this point, if you had a resource quota in your namespace, but you did not have any, any limits or requests, then your resource quota couldn't be applied. So you want to have something that says, okay, if there is a resource quota in the namespace, let's make sure that there are requests and limits. And so to do that, we do what's called enabling the cache in GateKeeper. Now, one of the things that unfortunately you can't do yet with GateKeeper, at least I don't think you can, is push data into GateKeeper the way you can with generic OPA. What you've got to do is you got to tell GateKeeper to pull that data into the cache. And so what we are going to do is we are going to create this Rego here. Oh, do I actually already have this? YAML config. I do. Okay, cool. So we already have this for you. Let's go ahead and create it. So let's go into enforce memory, YAML, and then kube control create config. So what this configuration is doing is it's telling GateKeeper, we want you to sync in all namespace objects and all resource quota objects. So now GateKeeper has that information available that we can use in our policies. So then we're going to go ahead and we're going to create a few namespaces. Some namespaces have quotas, some don't. So all right. Okay, cool. So let's go kube control create F namespace with quota. So we created one namespace that has no quota in it. We created one namespace that has a quota in it, and we created the actual quota. So now, if what we want to make sure that happens is when we create a pod inside of the namespace with quota, it better have limits on it. One thing to point out is that the GateKeeper service account has access to everything in your cluster by default, including secrets. There is no security in OPA. OPA has no idea of security. Any security you want to build to it, you got to add, which means if you put secret in here, it's going to get synced into the secrets database. So you probably want to avoid that. Really should be writing policies against secrets. So here we talk, so I'm on page 277, and we talk about mocking up the test data, and I think I actually have that over here. No, maybe? I thought I did. Well, here's the test. And so we actually go through and mock up what the data looks like. And then we have our policy. So let's take a look at it in enforce.rego. Again, the Rego itself is pretty straightforward. We're going to get all of the namespaces with resource quota. We're going to get all the containers in those namespaces. And then the OK containers are the ones that have a memory request. And then finally here on the last line, all the containers, all the OK containers. If they're the same, great. If they're not, it's an invalid request. All right, so let's go ahead and first see if I can deploy with BusyBox in our new namespace. So kube control run temp shell rm I tty image BusyBox namespace with quota bin bash. Oh yeah, so I guess this already had it in there. But let's go ahead and enforce it anyway. So let's do kube control create f. Where am I? Gatekeeper policy template and gatekeeper policy YAML. All right, so let's try running this again, and we should get that it fails because of our constraint. Yep, there it goes. So even though Kubernetes, it turns out not to be as great of an example as it was when we originally wrote the book because that's now enforced. But you can see here that our admission controller is failing because we're not specifying memory. So that's how you go ahead and you write against policies that are in Kubernetes. So everything we've talked about so far has been on validation. Is the input correct? Mutation is actually changing things. Now, I've done mutations with Rego. I ain't gonna lie, it's painful, and I will never do it again. And thankfully, Gatekeeper does not require you to use Rego to do transformations. Rego is a great policy language, is not a great programming language, not a great transformation language. And so one of the things that is great about Gatekeeper is it does have a pretty simple mutation language that you can use. And one of the things I'm a huge fan of is sane defaults. Making sure that if you want everything in your cluster to look a certain way, make that the default. You want to have run as user specified. You want to have user IDs specified. You want to have capabilities specified. We're going to talk a lot about this in the next chapter. Make that the default. If it's not there, go ahead and add it. And so that way it makes your YAML more portable. You don't have to assume certain user IDs, as an example. It makes it a little easier to create YAML because now your developers don't have to worry about the 35 things that they have to add for security to their pods, because 99% of those things are going to be the exact same for every single pod. So I'm a big fan. Same defaults, mutation, you're going to make your life easier. And so let's go ahead and enable mutations in our cluster. And so we're going to apply the mutation objects. So now the mutation manager is running. And I'm on page 280. And let's see, I'm pretty sure default user. So add default user. So this is the mutation that we're going to do. We're going to say to every pod in a namespace, except for kube system, if run as user is not set, must not exist, set it with the value 7391, some random value. And so this means that whenever we run a pod, if we don't actually assign a user ID, our mutator will do that for us. So let's go ahead and create that. So I need to go up a directory. All right, so that creates our default user. And then same thing on privilege. We're going to say, you know what? As long as somebody has not specifically set the privileged flag inside their security context, let's make sure we say that's going to be false. Excuse me. So now let's go ahead and let's make sure. So we don't actually set a user in Open Unison. Let's see here, what did I do wrong? Get pods, L. Yeah, there's no, it comes back as an empty set. Okay, I see what I did here. All right. So what we're doing is we're saying get all the pods and let's get the JSON path of the security context. And it's coming back as empty because our default pods don't set the security context. So let's go ahead now and delete our pod. And now when the operator comes back, we're going to check again. And because of these two policies, we'll see that it's set as unprivileged and it's running as user, 70391. So let's run that same command again. And now it's running as user 70391. And so now what we're going to do is to show, okay, well, let's go ahead and run as a specific user. So what this is doing is we're going to patch our operator. We're going to set the security context to 19307, again, just a random ID. But what we want to do is show that the mutator is only going to run when the value is not present. So it's been patched. And now, I'm going to give it a second. We'll see that's firing up a new operator. And now it's running as 19307 because our mutator said, oh, it's already got to run as user. Let's leave it alone. So this is how you build same defaults inside of your cluster. This is how you run a more secure cluster, because now instead of the default being whatever your container says it is, if your container says I'm root, I'm root. Whereas now if I launch a BusyBox container, I'm running as 19307, so a lot of my escape scripts aren't going to work anyway because they require root access. And so it's not just enforcing it, but it's also making it easier on your developers as well. And I think that brings us to the end. Oh, no, we're going to run the exact same test, this time on privilege. Right. Oh, there. So privilege is false because I should have run this before I created it, but it's false because the mutator's in there. And so that brings us to the end of the chapter. Next time, probably gonna, maybe we'll do next week since KubeCon's later this week. Help you on your KubeCon hangover. But next time we're going to get into node security using everything we learned in GateKeeper and go through those labs. So thank you for joining us. Please hit that like and subscribe button or smash it. Just, not too hard. I don't want you to break a keyboard or your mouse. Um, and take a look at our other videos. Hope you bought the book and enjoy it. Feel free to drop us a line. We love to hear from folks that are reading the book. And yeah, so thank you. Have a great day.